Hello everyone. Today I am going to demonstrate the interfacing of an analog to digital converter module with an 8085 microprocessor kit and show how analog voltage is converted into digital data. An analog to digital converter or ADC is an electronic device that converts a continuous analog voltage into a discrete digital value. The module used here is an 8-bit ADC, which means it converts the input voltage into an 8-bit binary number. Now coming to the hardware setup, the ADC interface module is connected to the 8085 kit using a 26-pin flight-driven cable. The power supply and ground are connected properly, and the jumper is set to select the internal voltage source. A potentiometer on the module provides a variable analog voltage between 0 and 5 volts, which is applied to channel 0 of the ADC. The module also has 8 LEDs that display the digital output bits. Each LED represents 1 bit of the binary output. If a bit is logic 1, the corresponding LED glows. If the bit is 0, the LED remains off. Now, let us see the program operation. The program initializes the 8255 interface so that port A works as input and port C works as output. Then it selects channel 0 of the ADC, sends the start of conversion signal, waits until the end of conversion signal is received, enables output, reads the digital data from the ADC and displays it on the LCD display. Now I will execute the program. First, I set the potentiometer to minimum voltage. As you can see, the display shows digital data 00. This corresponds to 0 volts input. So all LEDs are off. Next, I slowly increase the voltage. As the analog voltage increases, the digital value also increases and the LED pattern changes according to the binary equivalent of the digital value. This shows that the ADC is converting analog input into digital output continuously. Now, I rotate the potentiometer to maximum. The display shows digital data FF. This corresponds to approximately 5 volts input. In this case, all LEDs glow. This confirms that the ADC output is at its maximum value. The program continuously repeats this process, so whenever the input voltage changes, the digital value and LED pattern update automatically. To conclude, this experiment demonstrates how an analog signal can be converted into a digital value using an ADC and read via microprocessor. We observed that minimum voltage produces digital value 00, maximum voltage produces FF, and intermediate voltage produces proportional digital output represented in binary through LEDs. Thank you.